Our third and final type of equation that we'll take a look at in this section are absolute value equations. Now, if we had just absolute value of x equals, let's say, 7, hopefully we know that there are two possible answers to this equation. Of course, there's 7 because the absolute value of 7 is 7, but there's also negative 7 because the absolute value of negative 7 also equals 7. So there are two solutions to this, and that's often the case with these absolute value equations. Now, again, there's the possibility of extraneous answers that we'll check for on these, but for the most part we're going to end up with two answers, especially if there's no x over here on this side of the problem. Now, the approach that we take then to solve is to split the problem into two parts. And so what we could have done here is we could have said that x equals the positive version of what we see here, or x could equal the negative version of what we see there. Pretty simple in this case, since there's not a whole lot of work to do inside that absolute value to solve for x once we do that. But we're going to use that idea in the examples that we're going to look through here. So first off, I need to have my absolute value isolated, which it is in this example and it is in the next one. If I had like an extra 3 added on to this, or a 2 that was multiplying the absolute value, I would first have to treat it as like a giant variable that I'd have to isolate before splitting the problem in two. But here I don't have those concerns, so I'm going to just split the problem in two straight out. And so the first thing I'm going to write down is basically the equation as I see it, just without the absolute value. So I'm going to say that 4x minus 1 could turn out to equal 11, and that would be good for us, which of course is correct. If I look inside the parentheses there, as long as what's inside equals 11, then that's a valid result. But also, what's inside that absolute value could also turn out to equal negative 11, because then I would apply the absolute value and then it would turn it into a positive. So this is what I mean by splitting the problem into two separate equations that we're going to solve. So we're going to take whatever's inside the absolute value and set it equal to the positive and negative of whatever we have on the other side. So now we can just go ahead and solve these two-step equations. So I've got 4x equals 12. I'm going to divide both sides by 4, and so I get x equals 3 as one of my answers. And real quickly, I can go ahead and plug that in. 4 times 3 is 12. 12 minus 1 is 11. Absolute value of 11 is indeed 11. And so now I can just go ahead and solve this other one. So I'm going to add 1 to both sides. So we get 4x equals, careful there, that's negative 10. So if I divide both sides by 4, we're going to get x equals negative 10 fourths, which reduces to negative 5 halves, or negative 2.5. And so again, I can go ahead and plug that in. If I multiply 4x times, easier if I leave it in this unreduced form, 4 times negative 10 fourths is going to be negative 10. Negative 10 minus 1 is negative 11, the absolute value of which is 11. So both of these answers check out for us. In our final example, we're going to take the same approach. The absolute value is already isolated, so we don't have any preliminary work that we need to do. So we're going to split the problem in two. We're going to take x squared plus 4x, what's inside the absolute value, and set it equal to what we see, 7x plus 18. And then I'm going to take that same thing, x squared plus 4x, and then I'm going to set it equal to the opposite. So over here, that opposite was a little bit easier. We just made the 11 into negative 11. This time, we're going to have to take the entire expression and multiply it by negative 1. So we've got these two quadratic equations, as it turns out, since we have an x squared in both of these. So we're going to get a lot of answers that we're going to need to check to see if they work when we're all done. We're going to get 2 from this part of the problem. We're going to get 2 from over here as well. So in order to solve these equations, we've got to gather up everything on one side and then see about factoring or using the quadratic formula or whatever technique we want. So I've got x squared. I need to subtract this 7x from both sides. So that's going to give me a negative 3x. I'm also then going to have to subtract this 18 from both sides. So I'm going to get minus 18 equals 0. So I'm going to try to factor this. I have x and x. I need two numbers that multiply to make a negative, so I need a positive and a negative. I need two numbers that multiply to make 18, but have a difference of 3, since one's going to be positive, one's going to be negative, and the bigger number needs to be negative, so it's got to be plus 3 and minus 6. So now I can take each of those factors and set them equal to 0. So I can see I'm going to get two answers here, negative 3 and 6. But again, it's extremely important that we check our answers, because the red flag that we're looking for is we cannot have this absolute value over here end up equaling a negative number on this side. So that's really the key thing to look for. And I can see that if I plug in negative 3 into that problem, over on the left-hand side, I'm going to get negative 3 squared is 9, plus 4 times negative 3 is negative 12. It's going to work itself out. It doesn't matter what I end up with on that left side. What I can't have is a negative over here. And when I plug in negative 3 onto that side, 7 times negative 3 is negative 21, plus 18 means I get a negative 3, but an absolute value can't equal a negative. So that's the quick indication that that answer is going to get tossed aside. The 6, however, is going to be just fine. I'm going to get 36 plus 24 when I plug in 6 on the left. So we're going to get 60, and I'm going to get the same result. 7 times 6 is 42, plus 18 is 60. So far, 6 is good. So now we've got to solve the other version of the equation, where we set the absolute value equal to the opposite. So again, we've got x squared plus 4x. I'm going to distribute the negative here, so we've got minus 7x and minus 18. I'm going to port everything over. I'm going to add 7x to both sides. I'm going to add 18 to both sides. So all of this is gone. So we've got x squared, 7x plus 4x is 11x, plus the 18 equals 0. So I'm once again going to factor, and so I'm going to have x and x. I know I need two positives because I'm multiplying to make a positive and adding to make a positive in the middle. I need two numbers that multiply to make 18, but add to make 11, so that's got to be 9 and 2. And so if I take each of these factors and set them equal to 0, I'm going to get x equals negative 9 and negative 2. And so once again, if I want to check this in an efficient manner, I really am just looking at this right-hand side of the problem and making sure that I don't get a negative over there, because an absolute value, which is what I have on the left, can't equal a negative. And so right away I can see that negative 9 is going to be problematic, because I'm going to get 7 times negative 9 is negative 63, plus 18 is going to be a negative number over there, so I can throw that one aside. But that negative 2 is going to be okay. 7 times negative 2 is negative 14, plus 18 gives me a positive 4, and so I'm pretty confident that that's going to work out. So I'm going to add that to my list over here, and so here are my two answers to this question. So again, when it comes to these rational equations that we studied previously, these radical equations, and these absolute values, we have to be mindful about checking our answers when we're finished to make sure that those solutions are not extraneous.